Hello friends, myself Professor Rajendra Baburao Gharse. I am working as an head of electrical engineering department at NB Navle Sinhagad College of Engineering Solapur. I am having teaching experience of 9 years. I have completed BE in electrical engineering from Government College of Engineering Karad and MTech from Indian Institute of Science Bangalore. In the achievements, I have secured the All India 7th rank in the GATE examination with a percentile of 99.96. In my last video, we discussed about the Z parameter. Today, we are going to discuss about the Y parameters, right? As we know, as long as the two-port network is considered, we are having 4 types of the parameters: Z, Y, ABCD and H. Let us discuss the Y parameter. Okay, Y parameter are also known as short circuit admittance parameters. Why it is known as the short circuit admittance parameters, we are going to discuss. Okay, as we know, the Z parameter gives the expression for V1 V2 in terms of I1 I2. Similarly, the Y parameter gives the expression for I1 I2 in terms of V1 V2, I1 I2 in terms of V1 V2. So characteristic equations of Y parameters are I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 into V2. Okay, so these are the characteristic equations of the Y parameter, right? Now, as I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. Okay, so in order to find the value of V1, right, here V2 should be equal to 0, right? So V2 to be 0 means if output port is short circuited, if the output port, that is the second port, circuited, then V2 will become 0. So V2 will be equal to 0, right? So when V2 is equal to 0, so what about the, from equation 1 can we write I1 is equal to Y11 into V1? Yes, I1 is equal to Y11 into V1. So Y11 is equal to I1 by V1, provided that V2 is equal to 0, provided that V2 is equal to 0, right? As the Y parameter is the ratio of current to the voltage, that's why the unit is current to the voltage, means it is like a admittance, right? So unit of admittance is mho, so the unit of the Y11 is mho. Similarly, when V2 is equal to 0, from equation 2 can we write I2 is equal to Y21 into V1, right? So what is a Y21? It is a I2 by V1, right? So provided that V2 should be equal to 0, right? So Y21 is also a ratio of current to voltage, right? I2 by V1 means I2 is nothing but the output port current and V1 is nothing but the input port voltage, right? So it is again admittance, so unit of admittance is mho, right? So that's why. Next, for finding the value of Y12 and Y22, right, we need to, yes, short circuit the input port, short circuit the input port. So if the input port is short circuited, what is the V1? V1 is equal to 0. So from equation 1 can we write I1 is equal to Y12 into V2, Y12 into V2, right? So because when V1, if we put the V1 is equal to 0, then it will become I1 is equal to Y11 into 0, right? So that's why it is a 0. So Y12 into V2. So what is Y12? It is I1 by V2. So it is a ratio of voltage to, sorry, current to voltage, right? So unit is mho. Next, from second equation can we write I2 is equal to Y22 into V2, provided that V1 is equal to 0, right? So what is Y22? Y22 is equal to I2 by V2, right? Again, it is a ratio of current to voltage, so that's why the unit will be mho. Unit will be mho. It is a admittance, right? It is a admittance. So in order to find the Y parameters, yes, 1 and Y21, we need to short circuit the output port. In order to find the, yes, Y12 and Y22, we need to short circuit the input port, right? Y12 and Y22, we need to short circuit the input port. So that's why it is known as a short circuit admittance parameters, short circuit admittance parameters, right? Next, unit of all the Y parameters is mho. Very important point, the unit of all the Y parameters is mho. Unit of all the Y parameters is mho, right? Next, let us discuss some numericals based on the Y parameters or the short circuit admittance parameters, right? So while finding the value of Z parameter, generally the Kirchhoff's voltage law is preferred, right? Because in the Z parameter at the left hand side we are having the voltage, right? So generally the KVL is used. Next, in while finding Y parameter, generally the Kirchhoff's current law, that is the KCL is used, right? If we can find it by using the KVL also, but it will take some more time compared to that of the solution depending or based on the next. So Y parameters of the network shown in figure. Y parameters of the network shown in figure. First thing is, this is a two port network. Yes, right? V1 and V2. These two are the port voltages and the port currents are I1 and I2, right? I1 and I2. So it is a two port network. Our task is to find the Y parameters of this two port network. Y parameters of this two port network, right? So now, so we are going to use the KCL here, right? So what is the first step for KCL? Yes, consider this voltage or this as a reference node, right? So reference node potential we consider it as a 0 volt. Here it is 0 means here it is 0 0 and here it is also 0 volt, right? If here it is 0 volt, so what about the potential here? This potential difference is V1, right? And at the negative plate the potential is 0 volt. So what about the potential at the positive plate? Definitely it will be 0 plus V1, means it should be V1 here, right? So here it is a V1, here it is a V1, right? Next, if this is V1, what about the potential here? Right, this potential is also is equal to V1, right? Here it is 0 volt, this potential difference is V2. So what about the potential here? This potential is V2, this potential is V2. If here it is V2, what about the potential here? This is a V2. Okay, so potential here is V1, potential here is V2, means we have represented or we have assigned the node potentials, that is a V1 and V2. Next, assign the branch currents, right? Already they have given the current here is I1, current here is I2, right? Apart from that, we are going to consider direct current in this branch is I3. You can consider either it is in the upward direction or in the downward direction. In any way you can assign any direction, you are free to assign the direction to the branch current. Okay, so I have considered it is in the downward direction. Okay, current here is I4. I have considered the direction is from left to right, right? You are free to assign the direction of the branch current, right? If you want, you can change the reverse the direction of the I4. Next, the direction of the current in this branch is I5. I have taken it as a downward direction, right? So if you check the given circuit and the circuit which we have drawn in the answer, yes, here the changes we have considered the potential at these points is 0 volt, 0 volt, 0 volt and 0 volt here. So it is V2, here it is V1. If here it is V1, here it should be V1. If here it is V2, what about the here? Here it is a V2, right? After that, we have considered the branch currents, right? I2, I3 and I4. Next, can we apply KCL at V1? Yes, KCL at V1 means KCL at this node. Okay, so sum of incoming current is equal to sum of the outgoing current, right? Sum of incoming current is equal to sum of the outgoing current, right? Next, what? Yes, how many incoming currents are there at node V1? Only one, that is a I1, right? So I1 is equal to I3 plus I4. So we can write I1 is equal to I3 plus I4. Next, our task is to find the Y parameters. Means ultimately we need to write the expression for I1, I2 in terms of V1, V2. Okay, so I1 is equal to I3 plus I4, means we need to replace I3 and I4. We need to replace I3 and I4 in terms of voltages and resistor, right? With the help of Ohm's law, right? So with the help of Ohm's law, can we write the expression for I3? Yes, current in this branch is I3, that is the current in the 2 ohm resistor is I3, right? Now for direction of the 2 ohm resistor is in downward direction, right? Direction of the 2 ohm resistor is downward direction. As we know, current always flows from higher potential to the lower potential. So that's why here it should be plus, here it should be minus. What is the potential at the plus terminal? It is a V1. Potential at the minus terminal, it is a 0. So what is the potential difference? It is a V1 minus 0. That should be equal to 2 into I3. So from this, can we write I3 is equal to V1 minus 0 by 2 or V1 by 2? Yes, so I3 is equal to V1 by 2. Similarly, can we write the expression for I4? Yes, I4 is the current flowing through the 1 ohm resistor. Here the potential is V1, here the potential is V2, right? So what is the direction of the current I4? It is from left to right, right? So it should be plus here, here it is minus, right? So it is like v1 minus v2 is equal to 1 into I4. So what is I4? v1 minus v2 by 1. So I4 is equal to v1 minus v2 by 1. So I4 is v1 minus v2 by 1. I3 is equal to v1 by 2, right? So similarly further can we simplify it? So this can be written as 1 by 2 v1 plus 1 into 3 by 2 v1 and minus v2. So I1 is equal to 3 by 2 v1 minus v2. So can we write y11 is equal to 3 by 2 mho and y22 is equal to, here it is, minus 1 mho, right? Minus 1 mho. Next, this is the expression for I1. Similarly, can we apply KCL at V2? KCL at V2. What will the KCL equation? I2 plus I4 is equal to I5, right? I2 plus I4 is equal to I5. So KCL at V2. Yes. I2 plus I4 is equal to I5, right? So I2 is equal to I5 minus I4. We are interested in finding the expression for I2. Okay, so further can we replace I5 and I4 in terms of voltages? Yes, we already written the expression for I4. I4 is V1 minus V2 by 1. Next, what is the expression for I5? Yes, expression for I5. I5 means current in this branch, right? It is in the downward direction, so plus here, minus here, right? Next, so 0, here it is V2. V2 minus 0 by 2 is equal to I5, right? So it is a V2 minus 0 by 2, that is nothing but V2 by 2. So I2 is equal to this term. After that, rearranging the terms, we can get I2 is equal to minus V1 plus 3 by 2 into V2. Consider it as equation number 2. Compare equation 1 and 2 with characteristic equations of y parameter, right? So y11 is 3 by 2, y12 minus 1, y21 is minus 1 and y22 3 by 2, y22 is 3 by 2, right? Are you getting the point? So the preferable form for finding the y parameters is KCL, right? Kirchhoff's current law. Kirchhoff's current law for finding the value. So in my next video we will discuss some numericals, more critical numericals based on the y parameters. Okay, thank you, thanks for watching.